Hi, hello everyone, and welcome to this talk called Production Ready Lambdas with Node.js. Nice to meeting you all. My name is Luciano. I am an AWS Serverless Leader, certified AWS Solution Architect, and a Microsoft MVP. I work for a company called Fortiorem as a senior architect, and I will tell you about that in a second. And you might have heard my name probably if you have been bumping into this book called Node.js Design Patterns. If you have checked it out, please let me know what you think. If you haven't, please also check it out. I'd be really curious to hear what you think about that. And I'm generally very available online, so feel free to find me and ask questions, engage. You can find all my contacts there. By the way, all the slides for this talk are available online, so feel free to scan the QR code if you want to follow along. I'll be giving you a bunch of code examples and resources, so it might make sense for you to just grab the slides right now so that you can check out the details later. Now, a little bit about Fortiorem. We are a consulting company highly specialized in AWS and serverless. We have been helping tons of companies to get the best of AWS, do migrations from on-premise to AWS. We do training and cloud enablement. We build high-performance serverless application, and we also have been helping some companies to reduce their cloud bills. So if all of these things sounds interesting to you, again, feel free to reach out to me or reach out to the links and emails address that you see here in this slide. And there is one thing that you might like if you're interested in AWS. We also manage a weekly podcast about all things AWS. This is one of our favorite episodes, but there are tons of episodes. I think right now we have about 80 or 85 episodes. So lots of content there to check out if you like podcasts and AWS. So in the agenda, we have what is serverless, what is Lambda and how it works, our first Lambda in JavaScript, and then I'm going to be giving you many tips to try to make your Lambda as production ready as possible. So let's get to it. All right, let's start by trying to describe serverless. And serverless is a little bit of a contentious thing. Like some people will have very different definitions. So what I did to try to figure out what's the best way to describe serverless, what do you do these days? Of course, you go to ChatGPT and you ask the AI to fix all your problems, right? So when I asked what the hell is serverless, it gave me a very lengthy answer, and don't worry, we're not going to read all of it. But the main points are, it's a cloud computing model where the cloud provider manages the infrastructure and automatically allocates computing resources to execute code in response to events or requests. So it's a cloud computing model. There is infrastructure automatically allocated for you by the provider, and it works in this kind of event-driven fashion with responses to specific events. The other cool thing is that there are no servers to manage or provision. That of course doesn't mean that there are no servers. It's not magic. There are still servers somewhere. It's just as developers, we don't need to worry too much about where those servers are, how they are provisioned, and what kind of operating system they use, and other concerns that you might have been worrying about if you were going for a more traditional model in the past, like EC2 or other forms of virtual machine. The other thing is that around cost. So developers only pay for the actual usage of their application, not for the infrastructure. That basically means that you don't have to pre-allocate some kind of resources that you end up paying for as long as you own them. But it's more, if your application is running at a certain point because users are active and they are doing things with your application, then you're going to be paying based on how much compute are you actually using when your application runs. But if nobody's using your application, your cost should be zero or at least very close to zero. And finally, examples of serverless applications or serverless services include AWS Lambda, Azure Function, Google Cloud Function, and other platforms that allows you to execute code on demand in response to events without having to worry about infrastructure. Today, we're going to be focusing on AWS Lambda, just because this is my area of expertise. But of course, you can probably use some of the learnings for today in other contexts if you use other cloud providers. Okay, so if we try to summarize everything we just said, serverless is just a way of running applications in the cloud. There are servers, we just don't have to think about them, and we pay for what we use. And there are small units of compute, generally called functions or functions as a service, that are triggered by events. Now, what are the cool things about serverless, in my opinion? What are the benefits? And in my opinion, you can focus a lot more on the business logic, at least most of the time, just because the surface is much smaller and it's easier to just try to write down what matters for that particular function. That sometimes increases team agility because it's very easy to bootstrap a new project, it's very easy to experiment things, it's very easy to change features, it's even very easy to just rewrite an entire function in another language if you want to for any specific technical reason. So I found in my experience that when you work on serverless projects, it's just easier to change direction when something unexpected happens in the project and you need to adapt. There is some degree of automatic scalability. As I said, if your application is not getting used, there is no infrastructure allocated for you, you don't pay anything. At the same time, if your application gets a lot of users, suddenly the serverless model tries to scale automatically the infrastructure to adjust to the new spike of traffic. Of course, there are limits. We'll be talking a little bit more about those as well. But in general, you don't have to worry too much about scaling up and down because the platform will do a lot of all of that for you. Of course, it's not a universal solution. There are many use cases where serverless is a great option, but there are also cases where you might want to use something else, maybe something more traditional, maybe an entirely different architecture. So again, it's not a silver bullet for every problem. So we'll try to learn what are the cases where it works best and how to take advantage of it. And in other cases, it's still good to use other approaches. Now, my opinion is that we will be seeing more serverless in the future, even though we have been hearing about serverless for the last few years. I think still the adoption is not there yet, but I think the adoption is growing. So more and more companies will be using serverless. Therefore, we should be ready for it and we should know what it is about and when it is convenient to use it. Now, I mentioned that Lambda is one of the main services that we use in the context of AWS when we want to do serverless. So what is it about? Lambda is nothing else than a function as a service offering that you get in AWS. So the idea is that you write function and those functions express some kind of business functionality. And these functions can be triggered by different kinds of events. And just to give you some examples, the most common one is HTTP requests. You can use that to build, for instance, web APIs. But that's not the only thing you can do. For instance, you can write Lambda functions that react to new files in S3. And that allows you, for example, to resize a thumbnail or maybe process a CSV file and write the results somewhere else. You can also react to jobs in a queue, for instance, SQS. So you might have a lot of background tasks to process, for instance, sending emails. And you can just put them in a queue and then you can have a pool of Lambdas to be ready there to react when new events are available. And also in that case, Lambda will scale based on the workloads. So if there is nothing in the queue, no Lambda will be allocated. If you have a sudden spike of job to do, more Lambdas will be spun up to be able to respond to that increased demand. Another use case is when you have complex workflows with multiple steps and choices and loops and repetitions. You could be implementing that as a step function, which is nothing else than a graph with different steps. And some of these steps can be Lambda functions where you have your own custom logic. And finally, you can run Lambdas on a schedule. For instance, you can say, I want to run something every Monday morning, maybe to trigger, a report. You can configure a Lambda to do that. And you can, of course, invoke Lambdas manually if you have maybe something that you just want to run one-off or maybe for debugging of specific invocations of a Lambda. Now, let's try to understand how Lambda works, because it's something that I find is not always obvious. And I think there are some interesting details that is worth understanding if you really want to use Lambda well in production. Okay, let's imagine that this lovely robot is the Lambda engine. So let's try to use this example to see what happens when you actually run code in Lambda. So there is a new event coming into the engine. What the engine does, it needs to check if there is a Lambda that is associated to that particular event. So let's just imagine this can be an HTTP request. Now, in this case, let's assume that there is a Lambda associated to this event. So what the engine needs to do, needs to check, is there any instance that is already available to respond to this event? And in this case, we don't have one. So it's responsibility of the engine to create a new instance of that particular Lambda. And how does it create a new instance? It needs to get the code from somewhere. And in the case of AWS, the code is stored in S3. So the engine can take the code from that S3 bucket and use it to initialize a new instance of that particular Lambda function. Now that the instance is initialized, we can basically forward that event to this instance and let it process this particular event. Okay, at this point, we don't have to worry too much. The Lambda instance has been created, the event has been forwarded, and it's just running this code in the background. It's working really, really hard, but meanwhile, the Lambda engine can just observe things happening in the background and wait for other events. And so it happened that there is a new event, and again, the problem is, okay, we need to give this event to a particular Lambda instance. Right now, we have one Lambda instance, but this Lambda instance is very busy. So what can we do? We can create a new Lambda instance. And again, we just take the same code from the same bucket, we create a new instance of that particular Lambda, and we give it the event so that it can process it in the background. So now we have two Lambda instances that are processing two different events. They are working very, very hard, but they are in the background. So we can observe that happening and see what happens next. And what happens next is that the first Lambda instance finished to work on that particular event, and it has a response that is ready to be delivered somewhere. So we can take that response, send it back to the caller, and at this point, we can go back to REST and just wait for something else to happen. Now, after a while, we realize that that first instance of the Lambda has been idle for a while, so why should we keep that piece of infrastructure lying around if it's not really doing anything? So what the engine is going to do at this point is just destroy that instance and free up some resources. At this point, we get another response, and this time is from the second Lambda instance that we initialize. So we can just take that response, deliver it to the caller, and go back to REST. There is a new event coming in. This time we have an instance that has been already pre-allocated and has been already processing events and is not doing anything. So rather than just initializing a new Lambda, what we can do is just take the current event and just give it to the instance that it is idle. At some point, this Lambda is going to complete. We have a response. We're going to send it away. And again, you can imagine that after a while, there is nothing happening in the system and we can destroy this Lambda as well. So we just got a summary of how Lambda engine actually works. Events trigger Lambda executions. The Lambda code is stored in an S3 bucket. So we can create instances and destroy them on demand depending on if there are too many events or if nothing is happening in the system. And an instance can handle an event at the time. This is probably the most important piece of information. So that gives you an idea of how to think about Lambda executions and Lambda instances based on how many events you can have at the same time. If we want to go a little bit in more detail, you might want to know that Lambda instances run as micro VMs using open source software called Firecracker. Now, when an instance is created, this is generally called a cold start. It takes a little bit of time to just provision that particular instance. Of course, we are talking milliseconds and not hours or minutes, but it's still something that might affect you negatively, especially if you are doing web APIs and you want the responses to be very, very fast. Now, every Lambda instance can be invoked synchronously, and this is called the request response pattern, or also asynchronously. So you just fire an event and there is nobody really waiting for a response. A Lambda instance doesn't really know how it is invoked. From the function perspective, it's just a function call. It just takes inputs and it needs to provide outputs. So there is this orchestration layer that happens around it and manages all the different kind of invocations. It manages errors, it manages retries, and so on. So if we want to visualize this, you can imagine that the Lambda function is the code that we write as a function, like in code, and then we pass in an event and it just needs to return a response. Now, what are some of the limits of Lambda? And this is just to inform you on how to think about cases where Lambda can be actually a very good fit and cases where maybe you want to use something else. One of the most common and well-known limits is that you cannot execute a Lambda for more than 15 minutes. So definitely Lambda is not a platform for long-running calculation, especially if that's a monolithic type of calculation. There is a limit on the size of events and responses. For asynchronous invocation, the limit is 256 kilobytes. For synchronous invocation, that limit is 6 megabytes. There is a limit of 1000 concurrent execution, but this is also a soft quota because that seems like a small amount. but it's something that if you have a good use case where you need a lot more Lambdas, you can open a ticket with AWS and they will increase that quota for you. And there is a max code size, which is 250 megabytes. So that kind of gives you the idea that you cannot write huge applications and just deploy as Lambdas. You probably might want to break them down into multiple Lambda functions. Now, on the 6 megabyte event response size, this has recently changed because there is a new feature called response streaming that you can use to go over that limit. And of course, there is some extra cost and there are some interesting details. I'll leave you to the documentation if you want to figure out more about that. Okay, how do we calculate cost for Lambda? And there is a relatively simple formula, which is basically in general, you pay only for when you are using Lambda, but how much do you pay? And the formula is basically depending from the amount of memory you allocate for that particular Lambda and the time that that Lambda is actually running. I'll try to give you an example here. Let's just say that in a specific region, the cost of 512 megabytes allocated is this amount of money, 0.0000083 per millisecond. So let's just say that we execute that particular Lambda for 15 minutes. In order to calculate the cost, we need to take that unit value and multiply for the number of milliseconds that Lambda has been running. And in this case, we get $0.07. Which is, terrible joke, but just to give you the idea that you can effectively, if you know the memory and the cost per memory, you just multiply that cost for the number of milliseconds, and this is how much you're going to be paying for that Lambda execution. Now, this might seem like a very low amount of money, and most often it is, but imagine that you have thousands of Lambdas running in parallel for a long time. That amount can easily get into the order of thousands of dollars. So always keep an eye on cost. Now, so far we didn't talk about CPU, we just talked about memory. So what about it? Well, you don't explicitly configure CPU because the CPU scales based on the amount of memory that you provision on that Lambda. And there is a table that we can observe to try to understand how many CPUs you get based on the amount of memory that you provision. So between 128 megabytes and around 3 gigabytes, you get 2 virtual CPUs, and that increases depending on giving it the Lambda more and more memory. So sometimes you might want to have more CPUs, even though you don't need too much memory. And the only way to do that is to just increase the memory anyway. So let's try to write our first Lambda in Node.js. Let's see how does that look like. And as we said, it is just a function at the end of the day. And the shape of the function looks like this. It can be an asynchronous function because, of course, we might want to do asynchronous operations inside this execution. And this function receives an event and a context, where the event is basically the input for the function. The context represents the current running context, and it's an object that we can use to read useful information about the context. So what do we generally do inside a Lambda? We get some kind of data from the event. If it's an HTTP request, maybe we want to read the body of that HTTP request, the method, the path, and we can use that to run some kind of business logic. And then at the end, we return a result. Now let's see a little bit of a slightly more realistic example. For instance, here we want to create some code, a Lambda function that receives a URL in the event, and it checks what's the status code that happens if we do a GET request to that particular URL. So what we do here, we extract the URL from the event, we use fetch to make a request to that particular URL, and then we return the status code of that HTTP request. Now, you can imagine that you can use this as a health check of some kind to check if a specific URL is still working well. Amazing, congratulations, we have written our first Lambda. So now how do we make it production ready? And let's start to explore some ideas that I think you should think about when you are thinking to provision a Lambda in production and actually run it for your own customers or your own business needs. The first suggestion that I have is to use infrastructure as code. You should stop right now to do things manually in your AWS account. Like, trust me, don't do it. Stop it and try to do something else. Possibly use infrastructure as code. And the reason why is that doing infrastructure as code means that all your infrastructure is defined as code, which means that you can keep it in Git, you can version it, you can create pipelines that allow you to deploy automatically every time something changes. And most importantly, this way you keep all your environments reproducible. And if you do any change on the infrastructure, because maybe you want to provision a new database, you want to provision a new Lambda, you can test all of that incrementally and then deploy the changes incrementally also in the production environment. Now, there are many tools to do infrastructure as code, and the list is growing pretty much every month. The main one are the likes of Terraform or CloudFormations or SAM or Serverless Framework or CDK. But just to give you an example, I want to show you something using SAM. Now, SAM uses YAML as the way to define infrastructure as code, and is specifically taught to help you to build serverless application without having to write too much code or very verbose infrastructure as code. It is great when you have to go just beyond one Lambda. So maybe you have use cases where you have a Lambda that needs to connect to an S3 bucket, maybe write information to a DynamoDB table. So you want to provision all the different pieces of infrastructure and make sure you connect the dots in the right way, giving the right access and the right permission to the Lambda so that it can interact with the other resources. Now, some example use cases, as I said, Lambda with DynamoDB and buckets. And the cool thing about SAM is that it supports everything that is natively supported by CloudFormation, which is the original infrastructure as code tool that is given to you in AWS. But it kind of gives you some syntactic sugars that you can use to keep the syntax a little bit nicer and shorter. At the end of the day, what SAM does, it will basically convert that YAML code into YAML that is like pure CloudFormation YAML, and it will deploy through CloudFormation. So CloudFormation is both the YAML syntax, but it's also a service in AWS that is the one actually performing the change detection and deployment every time you want to do a new release using the CloudFormation code. Now, this is a SAM template, and in this one we are doing something very simple. We are just defining a serverless function, so a Lambda. It's a Node.js one, and also we want this Lambda to react every time there is a new S3 file. The second tip that I have is think about observability. It's important to observe all the things when we run in production. We want to know if something fails, possibly before our users start to notice that. Now, what makes good observability? You have to do good logs, good metrics, and hopefully good tracing. And if you do all of that, you are going to be reaching the observability nirvana. Sorry, another bad joke, but I couldn't help it. One way to do all these things in Lambda when you use JavaScript is to use a library called Lambda Power Tools for TypeScript. And don't worry if the name says TypeScript, you can use it even with plain Node.js. So let's have a quick look on how we can use it to make our Lambda a little bit more production ready. Of course, this is a third-party module, so we have to run npm install. And this library is actually split in 3 different modules, one for logs, one for metrics, and one for traces. And let's assume we want to try all of them. We are going to install all of them. Now, this is our current Lambda code. How do we start adding proper logs? Of course, the first thing we need to do, we need to import from this new library, and we import the logger. We create a new instance for this logger, and as you can see here, we can already specify a service name. That is going to make sure that every time we have a log line, this log line is going to contain that service name. And you will see that this is something very useful later for filtering and searching through our logs. Now that we have a logger instance, what we can do is basically use it to create new log lines. And we can say, for instance, logger.debug, we receive this event, and we can even pass objects to be logged together with our event. The next thing that we can do is that we can say we are checking this specific URL, and we can, again, log the specific URL. And finally, we replace our original console log with a logger info. And again, we just say URL status, and we can attach some additional metadata. How do we use it. That's it. We don't really need to do much, but we can also provide specific environment variable to our Lambda function, for instance, to say what is the log level that we want to keep, because this logger allows us to keep different levels. You can log things at different levels, but you don't necessarily want to store everything. So maybe in production, you just want to have the info type of log levels, while in your testing environment, you might want to have a different lower log level, for instance, debug, so you can actually check everything that is happening. When we provision this particular Lambda, if we go to CloudWatch, which is the service where we're going to be storing all the logs, you can start to explore all the different logs. And as you can see, because this is doing JSON logs for us, we can see a nice structure where we can see the different properties. And this way we can actually basically have an overview on all the objects that are being logged. The cool thing is that CloudWatch also has a query language that allows you to dynamically query through all your logs. And in this particular example, what we are doing, we are trying to see all the different URLs that have been logged and what was their status, and we can see a nice table that represents all of that. You can also do aggregation, you can count things, you can also limit things by date. So this is just an amazing tool when you want to try to troubleshoot a specific bug, to effectively try to investigate, use all the log information to get evidence on what's possibly going wrong so that you can start to fix it. Okay, then let's look at how we can add metrics to this particular example. So far we've been seeing logs. This is our current code. Let's add some metrics. And again, the experience is very similar. We have to import a few classes from this particular library that we just installed. We create a metrics client. In this case, we can specify a namespace and a service name. And then we can do a number of different things. In the case of metrics, we can just create a single metric, and we can add custom dimensions if we want to. And then we can, in this case, for instance, we are creating a metric that represents how many successful requests we had. And for every successful request, we just want to increase this particular metric by 1. And finally, we want to do publish store metrics to make sure that all these metrics get flashed to the underlying HTTP request that is going to send all this data to AWS. Now, once we provision this Lambda and we start to collect metrics, again, we can go to CloudWatch to observe this particular set of metrics. And we can see, we can create all kinds of dashboards, again, to monitor live what's going on in the system. For instance, here we are plotting how many requests of 4xx, requests of 2xx are happening over time. And we can also plot things as a pie chart if that's more convenient for the particular kind of observation that we want to have ready to just look at when things are going wrong. Now, I could also show you something about tracing, but I think that will take a little bit more time and it's a little bit of more advanced topic. So I'm just going to leave you the screenshot here, and I will send you to the Power Tools documentation to have more examples on how you could also add tracing in your particular application. You might be saying that observability is hard, and I'm not going to disagree with you. So the next question is like, how can I get something for free? And this has been actually a common conversation at ForTheorem and with our customers. So we ended up building a tool called SlickWatch that can help you to make observability a little bit less painful. And the way that SlickWatch works is basically saying, if you are using specific resources, what are the best practices in terms of observability for those particular resources? What kind of dashboards and alarms you should be creating in your CloudWatch account based on the resources you are using? So if you use a Lambda, there are certain kinds of alarms and dashboards that are very commonly used. So why don't we just provision those automatically? It does work with some CloudFormation and CDK and serverless framework applications. So if you use these tools for your infrastructure as code, you can easily use SlickWatch. So again, the idea is that you write your own infrastructure as code, and in general, you just take that and deploy it to AWS. What happens when you use SlickWatch is that SlickWatch is going to run just before you start your deployment. It's going to analyze all your infrastructure as code. It's going to decide to make some changes to update your infrastructure as code, basically adding dashboards and alarms for you. And at that point, the deployment continues, but you are deploying a stack that has been enhanced by SlickWatch automatically for you. Now, how do we use it? You have if you are using SAM, you have to deploy a CloudFormation transform macro. So there is an initial step that you have to do only once for your account. And once you do that, you can take advantage of SlickWatch. If you're using it with Serverless Framework, it's just a plugin that you need to install in Serverless Framework, and you can enable it that way. At that point, you can just add SlickWatch to your project. And the way you do it is literally by just adding this one line in the transform section in your SAM template. Optionally, you can also add more configuration. For instance, you might want to change some of the default parameters. You might want to disable certain things that are not important to you, or maybe enable certain ones that are optional. For instance, the ability to send all the alarms to an SNS topic that can allow you to integrate with Slack, or maybe to integrate with your own alarming system and receive calls on your phone when something goes wrong. So the final step is, once you have enabled it and configured it, you just deploy and basically running some deploy. And at that point, you will get an enhanced stack that contains a lot more observability best practices without you having to actually think and write and deploy all of these things yourself. Now, how it's going to look like before SlickWatch? Basically, you go to CloudWatch alarms and there is nothing. Once you have SlickWatch, you are going to be seeing something that looks a little bit more like this. So where for every single resource, there are alarms that have been provisioned for you. There are also dashboards that have been provisioned for you. And also these dashboards are by service, but also not just by AWS service, but your own application. You will have a dashboard that contains everything together. So a single pane of glass that you can just look at. And in case of an error, you can probably see more easily what's the correlation between things. If an HTTP request is failing, maybe you can see some errors in DynamoDB as well, and that maybe can help you to understand, okay, there is a correlation there, maybe the error is coming from the database, and therefore this is why my Lambda is failing. That kind of thing, it's much more visible when you have a dashboard like this. And finally, again, if you integrate the SNS feature and you use tools like the chatbots and Slack integrations, you can easily propagate these alarms into your own chat or your own alerting system. Okay, the next step is how can we avoid code duplication? Because this is a topic that is very common, especially when you start to build more complex applications in Lambda. And the problem is that you have a unit of code that is very small. So there are concerns such as validation, such as serialization and deserialization, that the first times that you go through this experience, you just end up copy-pasting across all your different Lambdas. And at some point you have 50 different Lambdas and you have created a mess that is very unmaintainable with a lot of code duplication. So your kind of traditional Lambda might look like this. You have your handler. At the top part of your handler, you do common things like decrypting environment variables from KMS, deserialize the content of the event, validate input, authentication, authorization. At some point, you have your actual business logic here. So here you actually do something useful with the event. And then when you have a response, you probably have to do more stuff. So you need to validate the output, serialize the response, handle potential errors, and only then you can complete your Lambda execution and return. So as you can see, there is a lot of boilerplate code happening here, and the piece that we care about is just buried there in the middle where you do something useful with the data. Now, again, in a big project with many Lambdas, all that boilerplate ends up being repeated a lot, and it's cause of confusion, it's cause of unmaintainable code. So can we avoid all this clutter by basically separating what's the pure business logic from a specific function from all that boilerplate? And this is something that I've been thinking a lot when I started to build my first serverless projects. And in the first company that I work with using serverless, we ended up creating this project called MIDI that has been then open source and maintained by the community. And what MIDI does is basically trying to solve this particular problem of code duplication, and it helps you to improve your Lambda functions, make them cleaner, make them faster in many ways. So if it's something that you use and if it's or something that you're going to be starting to use after this talk, please consider supporting the project and give it a star. So how does MIDI work? I'm just going to give you some very quick examples. This is our simple Lambda right now. What we can do with MIDI, we have to import it. We move all our business call logic, the pure one, into a dedicated handler. And then what we do is we use middlewares. So what we need to do in line 8 is midify the handler. This is how we call this procedure. So basically we make our pure business logic in its own handler something that can accept middlewares, and then we can attach multiple middlewares with this .use syntax. For instance, we can do KMS, encryption, decryption, input deserialization, validation, authentication, and so on. So by doing this, we are basically moving the pure business logic in one place where it's very clear, it's very maintainable and testable, and all the other concerns, we delegate them to middlewares, and we can write these middlewares once, we can write all the tests for those middlewares once, and easily reuse them across different Lambda functions. Now that's just a very simple example, and if you have been using things like Express or Fastify, you should be familiar with this kind of mindset. A slightly more realistic example, since we are using Power Tools, is that with Power Tools works with MIDI, and if you use both libraries together, it should help you to simplify your code even more. And for instance, in the case of the logger, we can simplify things by basically just use this inject Lambda context logger. And when we do that, we can remove, for instance, this line, because automatically the event is going to be logged for us. So that removes one line, and this is a piece of boilerplate that you will have in every single Lambda if you want to log the event. And in order to enable that, you need to set this environment variable, Power Tools logger log event. And there are other things that we can do. For instance, also for metrics, we can use the same pattern. And when we do that, we can remove this line publish store metrics, because through the middleware engine, using MIDI, you don't have to explicitly say now flash all the metrics. That stuff is going to be done for you. So you don't have to worry about maybe if there is an error, you don't even flash your metrics and therefore lose precious information. Okay, MIDI comes with a built-in collection of useful middlewares, for instance, validation, SSM, secret manager, app config, error logger, HTTP content negotiation, course headers, WebSockets, and many more. You can check out the documentation. It gives you lots of examples for every single middleware. And of course, it's very easy to create your own custom middlewares if you have very specific use cases that are not covered by the built-in collection. Now, why MIDI? Simplifies your code, makes it more reusable. You can focus a lot more on the business logic. This is the idea that is making serverless great, but in practice, you still have a lot of things that you have to do on the side. With MIDI, you can actually focus more on the business logic. So, if you really like MIDI, consider supporting Will Farrell. He is the current maintainer of MIDI, has been maintaining it for a number of years. He has been doing an excellent job. MIDI has millions of downloads per year, and I think it's all thanks to the hard work of Will. So consider supporting him with a sponsorship on GitHub. The last piece of advice that I have is around performance. How can we fine-tune our Lambda? And I already mentioned that if you provision more memory, you get more CPU. So you might be wondering, okay, if I have a very CPU-intensive workload, is it worth allocating more memory so I get more CPU and maybe completes faster? Like, what is the sweet spot between execution time and memory so that my Lambdas are fast and maybe they can be, or maybe they are cheaper, depending on what do you care about. And this is a very complex questions to answer to. So the best thing that you can do is to use a tool like Lambda Power Tuning that basically creates a step function with a bunch of different configurations for your Lambda, and it literally runs your Lambda and collects metrics to see what's the best option for you in terms of execution time and memory. And it gives you this kind of graph, and by looking at this graph, you might decide, okay, what is the sweet spot for me? Am I optimizing for cost? Am I optimizing for performance? or maybe I'm happy with something in between that is performant enough and not expensive. Now, there are a bunch of other suggestions that I can give you. So I'm going to go real quick and try to finish the talk this way. So you should be using the latest AWS SDK v3 because it's more modular, easier to test, and it's the one that is going to be supported going forward. You should be using a module bundler. If you use SAM, you can use ESBuild. You should be using TypeScript because you can easily get typed events and responses, and it's just easier that you write correct code that way. You should be reusing objects across invocation. For instance, if you have a database connection, you can initialize that database connection outside of your handler. And what happens then is that multiple invocations on the same Lambda instance will not have to re-establish the connection to the database, and that leads to faster code execution, cheaper Lambdas, better user experience, and so on. Do your configuration through environment variables because that allows you to create Lambdas that are more generic and they are easier to ship in different environments. For instance, your testing environment and your production environment without having to change the actual code. Your code should be exactly the same between test environment and production environment if you want to have the peace of mind that if your code works on the test environment, it's probably going to be working also in the production environment. And you can use services like SSM or Secret Manager when you want to provision sensitive information, for instance, an API key into your Lambda functions. Now, as a summary, what we learned today is that serverless is great because it lets you focus more on what's important for the business. Lambda is a great tool when it comes to write serverless code on AWS. We should do our best to learn and use infrastructure as code so that we can have deployments that are versioned and reproducible. And you can use Power Tools and Slickwatch to make your apps more observable. You can use MIDI to improve the code structure and have an opportunity to focus more on the business logic. And finally, you can use Lambda Power Tuning to optimize your Lambda configuration and figure out what's the sweet spot between memory and time. So I hope that this talk was worth it. I hope you enjoyed it. If you have questions, feel free to reach out to me. Again, you can get the slides at this link. I also have all the examples in a repository, so you can check out that link as well. And if you have any question, feel free to reach out to me. I'd love to answer them and chat with you. Thank you very much. Bye.